For part A, we want to find the value of t with r equals to 4 over 5. First, we substitute r equals to 4 over 5 into the given equation. Next, we cross modify to remove the function and then invert both sides. Next, we replace the equation and this becomes 4t squared equal to 4. After both sides divided by 4, t squared equals to 1 way or 10. Taking the square root, we gain t is equal to negative 1 and positive 1. However, since t represents time in minutes, t cannot be negative. Therefore, we extend t equals to negative 1 and the value of time in t equals to 1 minute. For part B, we want to find dr over dt. So we differentiate the equation given using the equation rule. Let's u equals to 4 times open bracket 1 plus t equals cos bracket and b equals to 9 plus t squared. Next, we differentiate s, u, and v. We can get u plus equals to 8t and b plus equals to 2t. Substituting this into the formula, we simplify step by step. Simplification, we obtain dr over dt equals to 16 4t divided by 9 plus t squared or square. For part C, we want to find the length of charge on the area on the circular mass. The formula on the area on the circle is A equals to pi r squared. We differentiate r and we replace to r. After then, we apply the change rule and substitute dr over dt obtained for part B. Now, we substitute r equals to 4 over 5 and t equals 1. After simplifying, we obtain dA over dt equals to 113 pi over 135 30 minutes squared per second.
Next, in part D, we are given a task to determine the range of values of t when the rate of change of r decreases. To do this, we must find the second derivative of r with respect to t, which requires the first derivative obtained previously. Then we see that the first derivative is a fraction. Thus, we must apply once again the quotient rule, where the numerator is defined as a and the denominator defined as b. Then, we must compare the second derivative of r with respect to t to 0. And for the rate change of r to decrease, d2r dt squared needs to be less than 0. And after doing the equation, we find that there are two possible answers for the values for the range of t, which is t less than negative of square root 3 or t greater than square root 3. Since time is always a positive value of 0 or greater, t less than negative square root of 3 is rejected, thus only leaving one possible answer, which is t greater than square root of 3. Thus, the range of values of t is t greater than square root 3. Finally, the task for part E is to determine the limiting value of r. And to do so, we must find the limit of the function as t approaches infinity. These are our workings, and we find that the limit of the function when t approaches infinity is equal to 4. Therefore, the limiting value of r is 4.
For part A, we are given an equation from the question, which is dv over dt plus 0.25v equals 10. Express dv over dt in terms of v, which is dv over dt equals 10 minus 0.25v. We then express dv in terms of dt, which gets us 1 over 10 minus 0.25v dv equals to dt. Both sides are then integrated, which gets us 1 over negative 0.25 ln 10 minus 0.25v equals t plus c. We will mark this as equation 1. From the question given, we assume that the initial velocity of the object is 0. So when t equals 0, v is also equals 0. These two variables are then substituted into the equation, which gets us 1 over negative 0.25 ln 10 minus 0.25 times 0 equals 0 plus c, and we will get c equals negative 4 ln 10. C is then substituted into equation 1, which gets us 1 over negative 0.25 ln 10 minus 0.25v equals t minus 4 ln 10. Negative 4 ln 10 minus 0.25v plus 4 ln 10 equals to t, and we get t equals to 4 ln 10 minus ln 10 minus 0.25v. The equation is then simplified to become ln 10 over ln minus 0.25v equals t over 4. Both sides are then exponent, so we get 10 over 10 minus 0.25v equals to the exponent to the power of t over 4. And to make the equation simpler, both sides are then inverted, so 10 minus 0.25v over 10 equals to exponent to the power of negative t over 4. So both sides are multiplied by 10, which then gets us 0.25v equals 10 minus 10 e to the power of negative t over 4, and we express the equation v in terms of t, which gets us v equals 10 minus 0.25v in bracket 1 minus e to the power of negative t over 4, which finally gets us v equals 4t times 1 minus e to the power of negative t over 4. For part B, we determine the limiting velocity and sketch the graph of velocity against time. So when t approaches 0, we can identify that e to the power of negative t over 4 also approach 0. So the limiting velocity, using the equation we got earlier in part A, we limit t approach to infinity in the equation 4t times 1 minus e to the power of t over 4. So when t approach infinity, e to the power of t negative t over 4 equals to 0. So 4t times 1 minus 0, we will get 4t. So the graph of velocity against time, it is an exponent graph which approach 4t.
For part C, we recall the velocity function from part A, which is v equals to 4t minus 4t exponential to the power of negative t over 4. Then we use the definition of acceleration, which is a equals to dv over dt. Next, we differentiate v, turning it into dv over dt equals to 10 exponential to the power of negative t over 4. Finally, we describe how acceleration varies with time. At t equals to 0, a equals to 10. As the increase, exponential to the power of negative t over 4 decrease. Hence, the acceleration decreases exponentially with time. For part D, we use the relationship between displacement and velocity. V equals to ds over dt. So, s equals to integrate v dt. Next, we substitute in the expression for v in s. Then, we integrate term by term and we get 40t plus 160 exponential to the power of negative t over 4 plus c. We apply the initial condition where t equals to 0. S equals to 0, so we get c equals to negative 160. We get the displacement function, which is s equals to 40t plus 160 exponential to the power of negative t over 4 minus 160. Finally, we find the initial height. When t equals to 16, s equals to 482.93 meter.